Welcome to Lab 2 or Tutorial 2 of Graph Connectivity in SageMath and how you can find this file. So basically, when you go to Brightspace, whether it's 255 or 249, you will find the new content have been published. So you go to Lab 2 onto graph theory, that's last week. And this week, we are focusing on the degrees of graphs. So in the degree of the graph, we have a lab to do, and we have also a video. So you open the page of the degree of a graph, then you see the video in YouTube. And once you finish, I want you to open this file, which is basically the same file that you can see here in Microsoft Word, where we are going to test the degree of a graph. In part one of this lab, I want you to represent those graphs in your computer. So I assume that by now you managed to install SageMath in your local computer, or you have an access to cocalc.com where you can sign in and you do the graph. Now, the downside of SageMath is basically this one is not allowing you to share your work. You have to pay in order to make this work shareable to different people. Now, the SageMath, once you run SageMath in your local computer, it will open something like this at localhost port 888 by default. And now you need to create a new file. So all you need to do is to put a new SageMath 8.5, which basically will open a new file called Untitled 2 with cells, and you can see the Sage icon here. Now, you might have a good practice or try to have like an habit where you can rename the file name lab3 demo. So I remind myself that this is where I create the lab in order to show you in the class. Now go back to the lab sheet, and in the lab sheet, he wants us to create a graph, and he said to complete this lab, make sure you complete the following tasks. We have a set of directed and undirected symbol graph and multi graphs as well. So we want to represent them. Now let me show you how you can represent the first graph, and let me call this G1, and G1 is a graph of 6 nodes. As I show you in the previous lab, you can at any time press Shift and Tab to get more information about the function. So this is the initial signature of the function, where you can basically pass the number of parameters, whether you want loop, you want to have a formatted weight, you want to pass a data structure, you want to pass, for example, a label for the vertex. Do you want to have multi-edges active? Do you want, for example, to have it sparse? Do you want to pass a matrix or a mutable matrix, and so on? So there is so many things you could do in this graph constructor to build a new graph. Now I will just create now an empty graph, and I will show you now how you can start chain the graph. So now G1, if you do G1 show, this is basically an empty graph. So there is nothing in this graph so far. Now let us start to add a new vertices and a new edges as well. Let me say, for example, G1 add vertex, and now I want to add an edge or a vertex or a set of vertices. Now let me just add one vertex, and I will call this vertex 1. Now put G1.show. Now that graph has a new vertex, which is basically called G1. Now maybe you want to add another vertex, which is basically add vertex, press tab there, and we will add now the vertex 2. Now if you look back here, maybe you are saying, okay, Basil, but we have now A, B, C, F, and E, and D. We don't have 1, 2, and 3. So you might just go back and you say G1, remove, delete, vertex, and I want to delete 1, and I want to delete as well 2, so I could add a new vertices in the right order. Now let's say G1 add vertex, which is the same function we used before. Instead of 2, I want to add A. Now you see now I pass A as a single character or a string. This is much easier to handle it later on. Now when you want to do g.show and then you run this, you can find that the vertex got the name A. If you pass A without single quotation, SageMath will give you an error because basically you have to be careful about that. Then now I will add G1 add vertex tab. When you press the tab, it will just auto-complete what you are doing, and we will add B. Now you look here, we have a vertex A and a vertex B, and now I want to wire them, or I make a connection between them. So I say G1 add tab, and there is something called add edges or add edge. I want to add an edge. Now you have no idea how to handle this add edge. You can press shift and tab, and this will tell you, please pass add an edge from U to V in the same format. So you can say G1 add an edge U to V, and you say, for example, I want to add from A to B. Okay, and then I press run. Now if I do G1 show, okay, I should be able to see now there is a new edge added to the graph, and so on. Now this is maybe a very time consuming, so there is a possibility that you can add all the edges all at once, all the vertices all at once, and then you add the edges as well as a set. You can do this using another method where you can do add vertices. Now, when you press Shift Tab, it will give you as well a file, and this file you can expand it and you read later on. So what he's saying now, with add vertices, I could use the data structure as an array and pass all the edges that I want. So all I want is a square brackets and add all of them all at once. So let me try this now and you see how I do it. So I managed to add A, I managed to add B. Now I want to add C, F, E, and D. So I will go here, single quotation, and I will say add C, single quotation, add F, comma, single quotation, add E, C, F, E, and finally, I want to add D. Now you could just, for simplicity, you write the word G1 after this code, after semicolon, which is basically will print the graph straight away. Okay, so now I have added all the 6 vertices that I need to represent the graph. All I need now is to use the G1 add edges, okay, which is basically you could say I want to connect B to F. So now let me wire B and wire F. Again, if you want just to show this straight away, so you don't spend lots of time doing G1.show, you can just write semicolon, and then you have basically G1 after that, and it will show the graph. Now, the other method I want to teach you today, where you can add multiple edges. So all you need to do, add edges, and now open the parentheses, and then press Shift and the Tab key from your keyboard to get access to the help. Now, if you expand the help, it will say to you, this method is basically used to add multiple edges to the graph, and he will give you multiple examples. So look here, add edges, all you need to do is to open a square brackets, okay? And you start to wire those edges as a subset with parentheses. So if I go back now, I add square brackets, I open the first parenthesis, and what left I need to do? I want to wire A to F. Let me close this help. I want to wire A and F. Okay, semicolon. I want to wire another parenthesis. I want to wire F and E. Okay, and I want to wire E and B, parentheses, and then I want to put E to B. I forget to put single quotation, and now semicolon, parentheses, I want to wire as well B, comma, C. Now later on the same method, okay, if anytime you feel you are not sure what you have done, so all you need to do is you keep the cursor here inside the method call, and then you press the help again. Later on, I will show you how you can label those edges, and this is how you label it. You have to pass the label after you say 0 is connected to 2 with label 1. But in the constructor, you have to be careful where you can make sure loops are none and show labels is set to true. You can learn all of these by practicing more in those methods. Now let me run. I believe now I am fine. So I have A connected to F, F connected to E, F connect E to connected to B, and B is connected to C. I could put semicolon G1 and run. So I make sure I could see the final product of the graph. I think there is something missing. If you look now to the original graph, A is connected to B and F. A is not connected to anything else. We have also B connected to F, and B is connected to E, and B is connected to C. Now also we have E, which is connected to B and connected to F, and we have C, which is connected only to B, but I believe the graph is correct, right? Now the D is a pendant vertex, is not connected to anything. So we finished the representation of the first graph, and now he said, find the degree of the vertex A in each graph. All I need to do is put the constructor G1 and look at D, press tab. Is there any function I could use to find the degree? Yes. So the degree, open a parenthesis, shift tab, so this is return the degree in plus out of the diagraph of a vertex. And now pass the vertex A, and it will tell you now the degree of A equals to 2. If you want to pass and test that this function is working, put degree and put it there, the name of the vertex, which is D, and check that it give you the correct answer, which is the degree of D is 0. So this is the first part, guys, how we can represent a simple graph and find the answers. Now in question B, he's asking you to find the neighbor of the vertex. Maybe if you are submitting this as an assignment, you can write this as a comment and you paste it so I could see it, or you can change it to a markdown, sorry, so I could see it as a text, so you can basically label your work or your cells based on the need of those cells. He's asking me to find the neighbors. How I can find the neighbors? I put G again, dot, and I put N, and then tab, and I will see if there is any method to give me the neighbors. And here I have a method called neighbors, open parentheses, press now shift and tab. It will return a list of neighbors in and out if a directed vertex of the vertices. And now I want to find the neighbors for the vertex B and press run. And he's telling me now the vertex B is neighbors to A, C, F, and E. Finally, for C, he wants us to display the adjacency matrix. So I put adjacency matrix and tab, and I find there is a method called adjacency matrix. Run this, and now G1, he wants me to basically put the incidency matrix, and I find a method to print the incidency matrix for this graph G. One. So now we managed to solve the first part of this. So in this part now, I want to show you how you can build a multi-graph where you have loops are enabled as well, and you have multi-edges. So we use the same constructor that we use in above. It is the same constructor that we use for building simple graphs. And you'll see now we have another one, which is basically for diagraphs. So when you have the constructor graph and then you open the parentheses and then you see what is basically the story, you can see now I could pass how many vertices I want and how whether I want to activate loops, and this is loops equal true. Well, do I need to show the vertex labels or the edge labels as well? And then whether I want to have multi-edges. Now, because this graph in graph 2, I have loops and I have multi-edges, I need to activate both of them. Now, look how many vertices we have in this graph. So we have A, B, E, D, 4, and 5. So we have 5 vertices in this graph. So I will say 5 vertices, comma, I want loops equal true, and I want multi edges equal. And you see now I don't really type the full thing. All I need to do is to type the few characters and then press the tab key, and it will auto fill what I'm trying to say. Now I have G2 is a graph with multi-loop and looped multigraph on 5 vertices, 1, 2, 3, 4, and 5. Now you see now I have the Sage giving the vertices an auto numbers, but this will be changed once we add the edges. Now we go back and we say add edges. So we'll do it now all at once, and we pass square brackets, and we open now the first thing. Now the first thing is we have a vertex called A, and A is going to A because we have a loop. Then we have another edge, which is basically from A to B, and then we have comma, we have as well a vertex going from A to B, and we need to repeat this 3 times because I have 1, 2, 3. From A to B. Now you could finish by this and you just basically want to see how A now is behaving, and I agree with you. And look now, I have a new vertex called A and to B, and A also has a loop. You can also carry on and you say g.add edges, open a square bracket, and now we need to wire basically B, and B is going to D, comma, parentheses again, and I want to wire B with C, and I want to wire as well D to E, and then I want to wire E to A. And do I have a connection between B and E? I don't have a connection between B and E, so I will make it now. And you will find it really strange, just to keep you, to remind you that from E to B or B to E, basically in a simple or multi-graph, both, it does not matter, because basically here we have no direction. Now let me close this and just put G2 to make sure I have all the connections I need. You will find that Sage keep building, and keep basically those pendant vertices there. I could simply remove them, and I keep them there in purpose, so you know how you can basically remove a set of vertices. Delete. So whether you delete the edge or you delete the vertices, and now I will pass and I will say delete 0, 1, 2, 3, and 4. Now do show. So they are gone. Now later on, I could basically display this as a 3D if I like. So I make sure we are having show the 3D, should work, but maybe I don't have 3D plotting activated in my SageMath, but it will work later on. So don't worry about it. I need to activate it later on. I could do that. So now this is how G2 look. I have A with a loop, 3 connection between A and B, and it is perfectly done. I have one thing missing, which is the C. So now I simply do that by fixing it by doing add edge. And from the add edge method, I just say add C to C, and then run G2.show. So this is now a graph 2 in SageMath. Same as before, I could do G2 dotted degree of C, G2 degree of A, G2 neighbors of A, G2 adjacency matrix, and incidency matrix for the part, which is part 1. Finally, I want to show you quickly how you can do diagraph, which is basically, let's say we want to do the one which is at graph 7. So I will call this D7, and you will find there is a method called dia, a graph in Sage. And diagraph is basically the same concept we used before to build a directed graph. Now, from where I could know all of that, if you could go to the internet and look at SageMath documentation, you will find loads of, or online documentation, you will find loads of resources about SageMath. So I could go there, and basically you can search as well for a specific knowledge or terms. You can see lots of tutorials as well, and you can also get the reference manual. Now here, if you search about diagraph, it will show you all the methods that are associated with diagraph, and it will give you more example to test, for example, connectivity, to test the cycle, to test the path, to test the degree out and degree in, and so on. So you will find the manual of the diagraph really useful when you want to build or try different things in Sage. Now the diagraph is basically D-I-G capital. I wrote it with G small, so it was basically a mistake. And if you look back to our tutorial, we have a diagraph of how many nodes now? I have a diagraph with 1, 2, 3, 4 nodes, and I want to build this diagraph by simply passing the constructor. And now I go D7, add edges, straight away. And then I will add the method, and I want to say now, please make a connection from A to A. Now this is the first loop. Another parenthesis, I want to make a connection from B to A. And please note now, I have said B to A because this is the way how the connection is directed. And now I want to pass another direction from D to A. It will be a good approach, guys, if you finish one vertex at a time and you move clockwise or anti-clockwise so you don't get or you forget to write or to wire those vertices and edges. Then I want to make a connection from D to B. So now I finish vertex B. I move now to vertex C, and then I want to wire C, B to C again. And maybe if you are confused and you are not sure what you are doing, you do the same as I did before. You just check the graph is technically in the correct order. Seems to be I have an error. Edge from A to A because I have to add in the constructor to make sure that loops are active, true. And I have to make sure multi-edges also true. That was my mistake. And now I have to activate it so it's now enabled. I carry on. I find myself, I need to add more edges to D7. So I have to add more edges, semicolon, edges. And I carry on. I add the constructor with the first pair, which are basically the subset from C to D. And then I need to add from D to B. Do we have a connection from D to B? Yes, we do. Now from C, and do we have from D to C? We don't have from D to C. So now let me make that obvious from D to C. I think we are good if we put a final check to see we have all the connections we need. We only have one loop at A. We have two edges going to A. We have one edge going out from B, which is to A and to C. And we have one edge coming to B from D. Now at vertex C, we have an edge going to D, and from D, we have an edge coming to C, but I made this mistake because an edge coming from B, no, it's not, it's correct. So B to C is correct. This is basically B to C. And now finally, let me check the D. D, I have one edge coming from C, and I have one edge going to C, and one edge going to A, and one edge going to B. So just to check, for example, if I want to check the degree of the edge, including in, out, the degree of D in this graph, I have to pass single quotation is 4. Also in Sage, you can also check the degree, and you want to check the degree for in degree, for example, you want to see how many are coming to D and how many are going to D. So out degree, and then you pass the name of the vertex. In this case, I want to check D. So you will find now in degree to D is 1, out degree to D is 3. As I said in the class, normally the loop is basically calculated as 2. It will contribute 2 to the degree. So you have 1 out and 1 in, and we can prove this when we test the n degree for the vertex A. So you are seeing now 1, 2, and 3 for vertex A. And now we want to check the out degree of the vertex A, which is basically 1, because only the loop is going or outgoing from the degree A. So this is, guys, basically the first part of lab 3. And I want you now to scaffold on this, and maybe you try to attempt yourself how you can basically build or prove the handshaking theorem for any of these graphs after you represent them. And as well, I want you to make sure you can do the in degree and the out degree and neighbor in and neighbor out for a vertex like D. In Sage, you can write functions similar to Python. You say, for example, this is my print function. And in my print function, you are basically saying, I will pass a parameter and I will say print. And you say, for example, print the degree of a graph. Now you should learn all to do this by passing, for example, a graph like G, and you say G dot degree. Now this is, will get a graph called G, and then you return basically nothing. If you are good in Python, you will find writing functions in Sage straightforward. So now when I do my print and I pass, for example, D7, should pass the vertex as well. Let me run this again. And now the D7, my print is going to print this function. The degree of a graph for vertex A is basically 1. So you could write those, each one of these, before you start representing the graph as a separate function. And once you do so, you only call the function and you carry on. Now, the challenge for you, try to make sure you understand the handshaking theorem before you write the function similar to this. Start.